Greetings to all my viewers. My name is Dr. Vikash Kumar. I am an assistant professor in mechanical department, Manit Bhopal, and I am going to present first unit basics of hydropower generation. So before going into detail of this hydropower plant, I would like to tell all my viewers that this is a 5-unit course. Over the course of 5 unit, we will go through in detail of the construction and working mechanism of hydropower plant. Hydropower plant, as the name itself suggests, the water energy, hydel power will be used to generate electricity. Now before going into much detail, let's go through some basic concepts of hydropower plant. Electricity is an indispensable part of human lives. Without electricity, it is impossible to imagine our life these days. It means you can all imagine if we don't have electricity, what we will do. You must be aware of the fact that electricity is generated by utilizing coal, wind, water and solar energy. Among these sources, hydel energy is one of the sources which is used to generate electricity. Hydroelectric power is one of the most established and broadly utilized renewable sources of energy. To generate the power, it utilizes Earth's water cycle to generate electricity. Now, in hydropower plant, the working substance is water. So, water is abundantly available in nature. So, we do not require any extra thing in hydropower plant to generate this electricity. Our country is endowed with an immense amount of hydroelectric potential and positions. India ranks 5th in terms of exploitable hydroelectric energy in the world. You can imagine from this fact that how vast the hydel energy of India is. The power generated from hydroelectric plants is used for several purposes. So, after this briefing, I would like to go on what is hydropower. Hydropower or hydroelectric power is one of the oldest and largest sources of renewable energy which uses the natural flow of moving water to generate electricity. It means you can say that one form of energy is getting converted into other form of energy. Basically, kinetic and potential energy of water is being used to convert into electricity. Hydroelectric power is electricity produced from generators driven by turbines that convert the potential energy of falling water into mechanical energy. So, as I said, one energy is getting converted into other energy. Hydropower technologies generates power by using the elevation difference created by a dam or diversion structure or water flowing in on one side and out far below on the other. Hydropower projects are classified as large and small hydro projects based on their sizes. In India, hydropower plants of 25 megawatt or below capacity are classified as small hydro. So, in India, we have different classifications of hydropower plant based upon its generation capacities. As I told, hydropower plants of 25 megawatt below capacity are called as small hydro and comes under the purview of Ministry of New and Renewable Energy, MNRE, that is known as. Prior to 1989, the Ministry of Power was in charge of hydropower. Plant capacity of 3 megawatt and below was handed to the Ministry of New and Renewable Energy, MNRE, in 1989. Thereafter, many initiatives were taken by this ministry since for the promotion of small hydro, which included implementation of a UNDP GEF assisted technical assistant project called as optimizing development of small hydro resources in hilly regions of India and India Renewable Resources Development Project with IDA credit line having inter alia small hydro development component with a target of 100 megawatt canal based small hydropower projects through private sector participation. So, what I am trying to convey here is the government has also put its tremendous effort to increase the production from this hydropower, because most of the water sources in India are still not being used for generation of power through this hydel energy. So, by these government steps, more and more people can involve themselves in this hydropower generation. So, moving on, this subsequently plant capacity of up to 25 megawatt and below was entrusted with the MNRE in November 1999. The estimated potential of 21,133 megawatt from 7,133 sites for power generation in the country, including all the sources like small, mini and micro projects, was assessed by Hydro and Renewable Energy Department, that we in short called as HRED, earlier known as Alternate Hydro Energy Center AHEC of IIT Roorkee, in its small hydro database of July 2016. And in India, most of the hilly states contributes tremendously in power generation from hydel. For example, the hilly states of India, mainly Arunachal Pradesh, Himachal Pradesh, Jammu Kashmir, Uttarakhand, and constitute around half of this potential. Other potential states also contribute significantly in power production through hydel. For example, states like Maharashtra, Chhattisgarh, Kerala, Karnataka, these states also contribute significantly in power generation using hydel sources. Focused attention is given towards these states through close interaction, monitoring of projects and reviewing policy environment to attract private sector investment, because these will only succeed if the public as well as private entrepreneurs will come and join hand together to indulge in these kinds of activities. The state wise location, if you will talk about, then I am going to when you will also get, my all viewers will also get the detailed PPT for this presentation. In that I will show through a through an image the detailed state wise location of small hydro plant states and individual contribution of different states of India towards the total power generation. And in India, mostly all the states contributes in power generation. So now I would like to talk about the basic principle of hydropower. As I told you in the previous slides, the flowing energy of water will be used to generate power. So the power output produced from the water energy can be calculated mathematically using a simple relation. We have G multiply by Q multiply by H multiply by eta, that is efficiency, where P is power developed in kilowatt, Q will be the turbine discharge in cubic meter per second, H will be the net head available in meter, and eta will be the overall efficiency of turbine and generator, and G will be the gravitational constant, generally taken as 9.81. So using this simple relation we can obtain the power output produced from a hydropower plant. Now I would like to talk a little bit about cost of hydropower. As I said, hydropower can be used in abundance to generate power. Hydropower is an affordable source of electricity that costs less than most. It means comparison to other units like steam or solar or other sources, hydropower cost less. Hydropower relies only on the energy from the moving water, and states that gets majority of their electricity from hydropower are Himachal Pradesh, Andhra Pradesh, Odisha, Karnataka and Madhya Pradesh. So in these states this hydropower is dominant than other sources. Compared to other electricity sources, hydropower also has relatively low cost throughout the duration of a full project lifetime in terms of maintenance, operation and fuel. Additionally, the equipment used in hydropower facilities often operates for longer periods of time without needing replacements or repairs, saving money in long term. Facts about some hydropower plants in India. The Koyna hydroelectric project is the largest completed hydroelectric power plant in India. It has a power capacity of 1960 megawatt. The first hydroelectric power station was the Sindrapong hydroelectric power station. Tehri hydroelectric power plant is the highest hydroelectric power project in the country. Also, Tehri Dam is the tallest one in India. Now NTPC has taken over the project since 2019. Srisailam hydro power plant is the third largest working project in India. Nathpa Jhakri hydroelectric power plant is the biggest underground hydroelectric power project in India. Then Sardar Sarovar Dam is world's second largest concrete dam. So with these I am trying to put here is the facts about the existing as ongoing power plants, hydropower plants in India. Now I would like to talk about benefits of hydropower. The benefits of hydropower have been recognized and harnessed for thousands of years. In addition to being a clean and cost effective form of energy, hydropower plant can provide to the grid immediately, serving as a flexible and reliable form of backup power during major electricity outages or disruptions. For example, if you talk about steam power plant, there you need a continuous supply of coal and other material. If the supply of coal or the raw material cuts off, then the power generation will be disrupted, but that is not in the case of your hydropower plant. Here, if the water availability is ensured, this condition will ensure that the power production is continuous without any breakage. Now moving on, this hydropower also produces a number of benefits apart from generating electricity, like as flood control, irrigation support and water supply. Now few advantages of hydroelectric power generation: renewable and sustainable energy source. First of all, it is a renewable and sustainable energy resource. No greenhouse gas emission during power generation, no any gas emission, like we are not burning any kind of coal or we are not harming environment while generating this power. Then it provides reliable base load power. It means you can rely that hydropower plant will give us continuous supply of power without any breakage, without any shutdown. Allows for energy storage by controlling the water flow. In hydropower, we have a full-fledged control in the energy storage by controlling the water flow. Now there will be some certain disadvantages also associated with this hydroelectric power generation. I would like to put here: environmental impacts like habitat disruption and fish migration issues due to dams. Now everything's had goods and bads, so this hydroelectric generation also has some advantages, some disadvantages. If we are using some water for this power generation, one side we are getting some power, but at the same time on the other side we are disturbing, we are creating a problem for aquatic and marine lives, like your fish migration issues will come into play. Then initial cost of construction is also high in hydropower plant. Dependence on sufficient and consistent water flow. As I told earlier, if the water flow is affected, the power generation will be affected. Vulnerability to droughts and changing weather pattern. This is one of the major disadvantages associated with hydropower generation, because it depends upon water. If water availability is there, then only the project can run, but in some season, due to any factor, some drought is there or sufficient water is not available, the hydropower generation will suffer a lot. Now we will talk about some factors which are important components or constituent, you can say, in hydropower station. Number first will be water source. The process starts with a reliable water source such as a river, lake or a reservoir. The availability of significant water supply and the difference in elevation, which is also known as head, between the water source and the power generation sites are crucial factor for efficient hydroelectric power generation. The water source is a crucial element in hydroelectric power generation. It refers to the body of water such as river, lake or reservoir from which hydroelectric power plant extract water to produce electricity. The availability of a reliable and continuous water source is essential for the efficient and consistent operation of a hydroelectric plant. Now next comes dam or diversion structure. A dam or diversion structure is a fundamental component of many hydroelectric power plant. It is designed to control the flow of water and create a difference in elevation known as head. About this head we will talk in our subsequent lessons, between the water sources such as river, lake or reservoir and the location where the electricity will be generated. This controlled flow of water is crucial for harnessing the potential energy of water and converting it into electricity efficiently. Here is how dams or diversion structures work in hydroelectric power generation. Like I have segregated, I have divided the power generation into 4 to 5 subcomponents. Number 1, diverting water. Number 2, controlling water release. Number 3, creating water storage. Number 4, hydraulic head. And number 5, penstock connection. Now we will see in brief all these factors. Number 1, diverting water. In some runoff river hydroelectric power plants, a diversion structure is used instead of dam, And to my viewers, I would like to tell that in the PPT which I will share, you will get a diagrams also explaining all these components individually. The diversion structure redirects a portion of the reverse flow into a penstock which carries the water to the turbine and generator. The main river flow continues its natural course downstream. The diversion structure allows power generation without significantly affecting the reverse flow and causing major environmental impacts. Now, next factor is controlling water release. The dam has gates or outlets that allow for controlled release of water. By adjusting these gates, the rate of water flow can be regulated. This controlled release is essential to manage power generation according to electricity demand or other operational requirement. Now, next factor will be creating water storage. For reservoir based hydroelectric power plants, a dam is constructed across a river or valley to create a large reservoir. The dam blocks the flow of water, causing it to accumulate behind the dam, raising the water level and forming the reservoir, because as I talked in my previous topics, that head is essential for generating the sufficient power supply. Without this head, water will be insufficient to generate power. Therefore, this dam satisfy this condition of creating the appropriate head, which will be further used to generate power. The stored water in the reservoir acts as a potential energy which can be converted into kinetic energy to generate electricity. Now, I would like to explain hydraulic head first before going further. The height difference between the water level in the reservoir or upstream of the dam and the location of the turbine or generator is known as the hydraulic head. In my further slides, I will talk about net head, effective head when I will discuss this head in detail. The greater the head, the more the potential energy the water has and the more electricity can be generated. Now, next component comes penstock connection. Whether using a dam or a diversion structure, the controlled water flow is channeled into a penstock. Penstock you can understand by considering it as a pipe like structure which is used to transport water from point A to point V. The penstock is a large pipe that carries water. The design and construction of these structure require careful consideration of environmental and social impacts to ensure responsible and sustainable use of water resources for power generation. Now, I will explain penstock in detail here. A penstock is a crucial component of a hydroelectric power plant. It is a large enclosed pipe or conduit that carries water from a reservoir in reservoir based plant or a diversion structure in runoff river plants. Now, my viewers must be getting confused in what is this reservoir based plant and what is this runoff type plant. So, in the PPT which I will share, you can see clearly with the help of a diagram what is the difference between reservoir based plant and a runoff river plants. The penstock plays a vital role in the efficient transfer of water and potential energy to the turbine, where it is converted into mechanical energy and eventually into electricity. Now, there is some certain mechanisms associated in the working of penstock. I would like to explain the process here. Now, first is water intake. In reservoir based hydroelectric power plant, the penstock begins at the intake structure located at the base of the dam. This is where water from the reservoir is drawn into the penstock. In runoff type, the river power plants, the penstock starts at the point where the water is diverted from the river or waterway through the diversion structure. Now, next is transporting water. Once the water enters the penstock, it travels through the pipe, which is usually made up of RCC structure, reinforced concrete steel, or a combination of both. The penstock is designed to handle the flow of large volume of water, and its size and material are determined based on factors such as water flow rate, distance, and head height. Hydraulic head. The penstock is generally inclined or sloped to take the advantage of potential energy created by elevation difference or the head between water source and the turbine location. As the water flows through the penstock, it gains kinetic energy due to gravity which is harnessed at the turbine to generate mechanical energy. Now, next comes how to regulate the flow. The flow of water through the penstock can be regulated using gates or valves. By adjusting these control mechanisms, the flow rate of water to the turbine can be varied. This allows for better management of electricity generation based on demand fluctuations and operational requirements. Now, the fifth component will be the turbine connections. At the end of penstock, the water is directed towards the turbine. In my coming lectures, I will give a detailed and elaborative discussions on various types of turbine that a viewer need to know in this hydropower plant. Now, the output of the penstock will be connected to a turbine. The turbine converts the water's kinetic energy into mechanical energy. Now, after this, I would like to talk about electricity generation. The rotating turbine shaft is connected to a generator which consists of a coil of wire within a magnetic field. The mechanical energy from the turbine is used to rotate the generator, producing electricity through electromagnetic induction. Now, final will be return of water source. After passing through the turbine, the water exits the penstock and is channeled back into the river to a lower level reservoir, completing the cycle. Now, here I would like to ask my viewer to pay attention that even though water is abundantly available in nature, but while designing or while starting a hydropower project, one has to ensure that whatever water we are utilizing to generate this hydropower must be returned back to the initial source. So far whatever we have talked, you might have understood that the simple mechanism of generating this power is you are taking a water source, you are using either a diversion structure or you are creating a dam, then you are applying a penstock, through that you are making water flow from point A to point B, then you are allowing water to hit the turbine and then turbine will be connected with a generator and then that will produce power. But in all these effect, you have to ensure that whatever water we are using, whatever water we are taking from a dam or a river, it must be returned back, or not all, then at least maximum quantity of water which is being used has to be returned back to its initial water source. Because if we start consuming water or if we start not returning water to its initial source, definitely we are going to face water shortage in the upcoming times, because water is abundant, but this hydropower project requires a tremendous large quantity of water for it to be operated. So, if over a long time if we start losing water or if we do not recycle the water back to the initial water source, it will definitely cause shortage of water. So, now moving on, its proper design, I mean the design of the penstock, the construction and maintenance are essential to ensure the reliable and sustainable generation of electricity from flowing or falling water. Now, I would like to talk about the turbine. Turbine is the most important component in hydroelectric generation. This turbine will be common in almost all the type of power generation, may it be from steam, may it be from tidal, may it be from hydro. This turbine is common. So, basically this turbine, our main aim is to run this turbine. The turbine, in our subsequent lectures we will see the detailed construction and working mechanism of this turbine. This turbine has some blade like structure. In the PPT which I will share with you, you can see the structure of this turbine, where you will find some blades mounted over the entire periphery of the turbine structure. So, water in case of hydro or steam in case of steam power plant, here we are talking about hydro. So, we will keep our discussion focused to only hydro. Water at high velocity will come, it will strike the turbine blade, the impact will be very high, sufficient enough to run the blades. Then the rotor of the turbine shaft will rotate and the same turbine will be coupled with a generator. So, as the turbine shaft rotates, it will run the generator, and electromagnetic mechanism, as I talked previously, will be used to generate power from the generator. So, this turbine is the central component, is the key component in this hydropower generation, about which we will talk in detail in our upcoming lectures. So, the turbine is the central component of a hydroelectric power plant and plays a key role in converting the kinetic energy of flowing water or falling water into mechanical energy. which is then used to generate electricity. Turbine used in hydroelectric power plants are specifically designed to harness the power of water and are classified into different types based on their designs and operational characteristics. The most common type of turbine used in hydroelectric power project is the water turbine or hydraulic turbine. Now, before going further, I would like to give you a brief discussion upon this how turbine works in hydroelectric power generation. Here also I have separated into different categories. Number one, I will first discuss on the water flow. As the water is channeled through the penstock and reaches the turbine, its potential energy, which is a result of the hydraulic head elevation difference between the water source and the turbine, is converted into kinetic energy due to high pressure and velocity of water. Next comes blades. As I talked previously, blades will be mounted on the turbine. The turbine consists of a rotor with blades or buckets that are strategically designed to efficiently capture the energy from the flowing water. The shape and arrangement of the blades are optimized to maximize the energy transfer from the water to the turbine. Now, few important types of turbine that you need to know before moving further. There are many ways to classify turbine. Amongst them, the most important types of classification is impulse turbine and reaction turbine. Turbines can be classified into two main types, as I told, impulse turbine and reaction turbine. Number one, impulse turbine. In impulse turbine, the water jets from the penstock strikes the turbine blades and generates a high speed jet of water. The pressure of water acts on the blades curved surface, causing the turbine to rotate. Examples of impulse turbine include Pelton wheel or Pelton turbine and turbo turbines. Number second, reaction turbine. In reaction turbine, the water partially fills the blades, and as it flows through them, the pressure energy is converted into kinetic energy. The pressure remains relatively constant throughout the passage of water through the turbine. Examples of this reaction turbine will be Francis turbine and Kaplan turbine. In my upcoming lecture, I will talk in detail about this Pelton wheel and impulse turbine and then reaction turbine. Now, next comes turbine rotation. The force of the water hitting the blades causes the turbine rotor to spin or to rotate. The rotor is connected to a shaft which transfers the rotational energy from the turbine to the generator. Now comes generator connection. The rotating turbine shaft is connected to a generator. As the turbine spins, the generator, it induces an electric current in the generator's coil of wire, which ultimately generates electricity through the principle of electromagnetic induction. Wastewater discharge. After the water passes through the turbine, it exits the power plant and is typically channeled back into the river or the lower level of the reservoir. As I previously talked, the need to ensure that whatever water is being used must be thrown back to the main source from where it was taken. This ensures that the water is returned to its original natural course, maintaining the ecological balance. Now, turbine, as I already discussed, these are critical component in the process of hydropower generation. Their efficiency, design and proper operations are essential for maximizing electricity production and the overall performance of hydroelectric power plant, because all thing depends upon turbine only. If the head available is not being utilized properly, then the entire head will be wasted if the required power is not being produced. Now comes generator. The generator is also a vital component in hydroelectric power plant that converts mechanical energy generated by the turbine into electrical energy. It uses the principle of electromagnetic induction to produce electricity. The generator is usually connected to the turbine shaft, which rotates the generator's rotor. As the rotor spins within the stator stationary part, that is also called, it induces an electric current in the coils of the wire wound around the stator. This current is the electrical output of the generator. Now, I would like to discuss how the generator works in the context of hydroelectric power generation. Here I will talk about how generator works in generating power. Mechanical energy input. The rotating turbine shaft connected to the turbine supplies mechanical energy to the generator. As the turbine spins due to the force exerted by the flowing water, it turns the generator rotor. Now, I will talk about little bit rotor and stator. The generator consists of two main parts, the rotor and the stator. The rotor is the moving part which is connected to the turbine shaft. It typically consists of a set of electromagnets arranged around its circumference. Now, little bit I will talk about electromagnetic induction. Surrounding the rotor stator contains a coil or coils of wire forming an electromagnet. When the rotor spins within this stator, it creates a changing magnetic field around the coil of wire. The changing magnetic field induces an electric current in the coils of the stator through the electromagnetic induction. This current flows through the electrical connections and conductors of the power plant, eventually reaching the electricity grid. Now, at last, output electricity. The electric current generated by the generator is in the form of alternating current AC, since the rotation of the turbine and the rotor causes the magnetic field to alternate in direction periodically. Most of the hydroelectric power plant produces AC current, which can be easily transmitted over long distances. Now, before going further, I would like to introduce a little bit about transformer here. Before transmitting electricity to the consumers, transformers are being used to step up the voltage for efficiently long distance transmission over power lines. At the consumer end, transformers step down the voltage to safer level and distribution to home, business and industries. Now, integration to this power to the grid. The electricity produced by the generator is integrated into the larger electrical grid, where it becomes part of the overall energy supply. From the grid, electricity will be distributed to the end users and power to power homes, industries and various electrical devices. So, basically here I would like to conclude now that generators are essential for converting the mechanical energy from the flowing water to usable electricity, making hydroelectric power a reliable and renewable energy sources. Their efficient operation, maintenance and synchronization with the grid are crucial for maximizing the benefits of hydroelectric power generation. So, we have discussed in detail about the dam, then the water source, then the penstock, then turbine, then generators. Now, I would like to conclude this lecture by rewinding what we have discussed in this session. So, return to the finally water, as I told, will be returned to the original water source. After passing through the turbine in hydroelectric power plant, the water is returned to its original water source, which could be a river, flowing stream of water, lake or lower level reservoir. The return of water to the natural water source is crucial in aspect of sustainable hydroelectric power generation because of the following reasons you can say or you can consider. Turbine discharge. As water flows through the turbine, its energy is used to drive the turbine and generate electricity. After passing through the turbine, the water energy level will be significantly reduced. Then after, it has to pass through a tail race or a draft tube. The water that has passed through the turbine exits the turbine casing through an area called as tail race in impulse turbine, or it exits through the draft tube in reaction turbine. The tail race or draft tube directs the water away from the turbine and back into the original water source. Then controlled release. In some cases, the water rate of the water returning to the water source may be regulated to maintain the ecological balance of the river waterway. This controlled release helps mitigate any potential adverse impacts on the downstream, like environmental impacts, then aquatic life, then natural habitats. There are some certain environmental considerations that also we need to take care while designing or while operating this hydropower plant. Hydroelectric power plant operators and environmental agencies work together to ensure that the water is discharged responsibly to minimize any negative environmental effects. For example, they consider factors such as fish migration, water temperature, dissolved oxygen levels and sediment transport in the river or waterway. Sediment management is also one of the key factors. One challenge in hydroelectric power generation is managing sediment built up in reservoir. Sediment carried by the flowing water can be gradually accumulated behind the dam, reducing the reservoir's storage capacity and potentially affecting downstream ecosystem. Proper sediment management strategies are implemented to address this issue. Then we have a factor called as sustainable water use. By returning the water to its original source, hydroelectric power generation is considered a sustainable and renewable energy sources. Unlike fossil fuels which are consumed and depleted, water used in hydroelectric power plants can be used repeatedly as it is naturally replenished by precipitation and runoff. The process of returning water to its natural source is crucial aspect of responsible hydroelectric power generation. It ensures that the environmental and aquatic ecosystems are protected and that the hydroelectric power plant operates sustainably over the long term. By maintaining the balance between energy production and environmental considerations, hydroelectric power can continue to be reliable and environmentally friendly source of electricity. So, this is it for my first lecture. I will meet with you again in my upcoming lectures. In that, we will see in detail the further components of the hydroelectric power plant and the further construction and working mechanism of the individual components what are being used in hydroelectric power plant for power generation. Thank you very much.